Hello and welcome to the next lecture. So I'm going to continue to talk about data types and basic operations in R. In particular, in this video, I'm going to talk about subsetting objects in R. So there are a couple of different operators that you can use to extract subsets of R objects. The single square brackets, the double square bracket, which we saw in the previous video, and there's the $sign. So the basic kind of principles to remember here is that the single square bracket always returns an object of the same class as the original. So the subset of a vector you are going to get back is a vector. If you subset a list, you are going to get back a list. Anytime you use the single bracket operator to subset an object, you will get the object of the same class back. So furthermore, the single bracket operator can be used to select more than one element of an object, with one exception that we will get to later. But double bracket operator is used to extract elements of a list or a data frame. It can only be used to extract a single element and of that object, either the list or the data frame, and the class of the returned object will not necessarily be a list or a data frame. So the idea with the double bracket operator is that remember that lists can hold things that are of many different classes. They don't all have to be the same. So the first element might be a numeric vector, the second element might be a data frame, the third element might be a complex vector, etc. And so when you use the double bracket operator to extract an element of a list, the object that comes back may not be a list, it may be an object of a totally different class. So that's what the double bracket operator is useful for. The $sign is used to extract elements of a list, again of a list or a data frame that have a name. Very similar objects can have names, and one of the reasons you have used names in an object is so that you can reference elements of the object by the different names. Otherwise, the semantics of the $sign are similar to the double bracket in the sense that when you use the $sign to extract an element of an object, it may or may not be of the same class as the original object. So here is the first example, a very simple vector, a character vector called x. And I'm going to use the single bracket operator to extract the first element. So here what I get back is another character vector with the single element a in it. If I try to extract the second element of x, what I would get returned back to me is a character vector with the element b in it. I could also extract a sequence of elements. So if I want to get the first 4 elements of x, I can construct the sequence 1 through 4 and then I get a, b, c, d. So in these 3 examples here, what I've done is I subset the vector x using a numeric index. So the numeric index is 1, 2 or the sequence 1 through 4. The another type of index that you can use is the logical index. So in this next example here, I'm going to subset the vector x and I only want all the elements that are greater than the letter a, right? So it might seem strange to you that I'm using the greater than sign with the letters instead of numbers, but there is a lexicographical ordering to the letters, and all the letters that are greater than A are letters like B, C, D, E, etc. So what I get returned to me is a character vector that only contains the letter that are greater than A. So here I've got B, C, C and D. The other thing I can do is I can create a logical vector which here I call U, which tells me which elements of the vector x are greater than a. So if I print out u, here I can see that the first element is equal to a, so it's not greater than a. Then the next 4 are greater than a, but then the last element is equal to a, so again that's false. And so I can subset the vector x with this u vector, and then I get out all the elements that are greater than a. So there are 2 types of indices that I use here. One, the first type with the numeric index, and the second type was the logical index. So subsetting a list is a little bit different because you can use the double bracket or the $sign operator. You can also use the single bracket operator. So here I've got a list. The first element is a named element called foo and it's a sequence 1 through 4. And the second element is named bar and it's the number 0.6. So this is a list of 2 elements in it. I can extract the first element by using the single square bracket, and remember the single square bracket always returns the element that's the same class as the original. So if x is a list, then x bracket 1 is going to be a list too. So what I get back is a list that has element called foo, which is a sequence 1 through 4. Now if I use the double bracket, then if I said x double bracket 1, what I get back is just a sequence 1 through 4. So the difference here is that in the first example I got a list that contained the sequence 1 through 4, and in the second example I got just the sequence. That's the difference between the single bracket and the double bracket operator. In the next example here I am using a dollar sign, and so I am saying x dollar bar, and what that means is that it gives me that element that is associated with the name bar. So in that case it's a single number 0.6. I can also use the double bracket operator and pass in a string. So x double bracket quote bar is the same as doing as x dollar bar, and it just gives me 0.6. If I use the single bracket with the name, I can say x bracket quote bar, that gives me a list with the element bar in it. So remember, because the single bracket always return a list if I'm going to subset a list. So the nice thing about being able to subset an element using its name is that you don't have to remember where it is in the list. So if I couldn't remember whether bar was the first element or was the second element, I don't have to remember whether what or where it is in the order to use the numeric index. I can just use its name, and then it will automatically extract that element from the list. If you want to extract multiple elements of a list, then you need to use the single bracket operator. So for example, if I want the first element and the third element here, in which case which is the foo and the baz element, I can pass a vector 1 and 3, the numeric vector 1, 3 to x using the single bracket operator, and that returns to me a list with the element foo and the element baz. So that's how I extract multiple elements of a list. There you cannot use the double bracket or the dollar sign operators when you only extract multiple elements of a list. The nice thing about a double bracket operator, which is different from the dollar sign, is that you can use the double bracket operator to index a list where the index itself was computed. So notice that when I used the dollar sign before, I actually typed out the word bar. I had to type out the name of the element, but sometimes the name of the element is actually the result of some computation. So for example, here I've got a list with 3 elements, foo, bar and baz, and then I create a variable called name, which is actually the string foo. So if I use the double bracket operator on this variable here, notice that there's no element in the list that has the name in it, but there is an element in the list that has the name foo in it. So now when I pass this variable called name into the double bracket operator, it returns me the element that was associated with foo, because that's what the value of the name variable is. So if I compute the index that I want to use, then I have to use the double bracket operator. If I use the dollar sign, then it's going to literally look for an element of the list that has the word name associated with it, and that of course doesn't exist in this list. So to use the dollar sign, I need to use a literal symbol. Now the double bracket operator can take an integer sequence in as rather than a single number, and the way you can think of this is that it kind of recurses into the list. So if you look at this current list I've got here with the first element A, which is another list which has elements 10, 12 and 14. So suppose I wanted to extract the number 14. Well, that's really the third element of the first element, right? So it's the third element of the list which happens to be the first element of the other list. And so I can extract the 1, 3 element term by passing the vector 1, 3 to the x list using the double bracket operator. And that's equivalent to kind of doing this double subsetting of 1 and 3. I can also extract the first element of the second element by passing the integer vector 2, 1 to get 3.14. Matrices can be subsetted in the way that you would expect. So the first index is going to be the row index, the second index is going to be the column index, and we can use numbers for this too. So for example, X is a matrix. It's a 2 by 3 matrix with the numbers 1 through 6 in it. If I take X with the 1, 2 in the single square bracket, that gives me the first row, second column, and so that's going to be the number 3. And then the second row, first column is going to be the number 2. You don't have to always specify both indices when subsetting a matrix. So for example, if I say X bracket 1, comma, and then blank for the second index, that notation indicates that I want the first row of the matrix, in which case this is a vector 1, 3 and 5. If I wanted the second column of the matrix, I could just leave the first index blank and say X bracket and then comma 2. that gives me the second column, which is 3 and 4. So by default, when a single element of a matrix is retrieved, is returned to vector of length 1 rather than a 1 by 1 matrix. So remember, I said that before, the single square operator always returns an object of the same class. So the one that's sometimes is a little bit unexpected is that if I subset out a single element of a matrix, I don't get back a matrix. What I get back is just a vector with that number in it. So if I say x 1 2, that gives me the first row, second column of the matrix. That's just a number 3, and what I get back is a number 3, not a 1 by 1 matrix with a number 3 in it. This is usually what you want, although sometimes it can cause problems, and so you can turn off this default behavior by adding an extra argument to the subsetting operation, which is called drop. The idea is that by default drop is equal to true, and it drops the dimension, and so rather than getting a 2-dimensional object back, you typically get a 1-dimensional object back. However, if you want to preserve the dimensions of the object, you can say drop equal to false, and when I subset out the first row, second column, what I get back is a 1 by 1 matrix with the element 3 in it. Now also, when you subset a single column or a single row, by default you don't get a matrix back. So for example, if I subset out the first row here, you might think that well, what should be returned is really a 1 by 3 matrix where there's 1 row and 3 columns and the elements are 1, 3, 5. Well, that's not actually what you get back. What you get back is a vector with the elements 1, 3, 5. Usually this is what you want, and it's okay, but if it's not, then you can always set the drop equal to false argument when you subset the matrix, and then you get a 1 by 3 matrix with the elements 1, 3 and 5 in it. This was all for now. See you in the next lecture where we will continue talking about subsetting in R. Till then, ciao.